You're watching Mrs. Perez, Module 3, Topic 1, Lesson 4. We're on page 481 in our book. The title of this lesson is 4 is better than 1, extending the coordinate plane. Right now, go ahead and try the warm-up. The warm-up says plot each point. As we've learned in the past, when we're talking about coordinates, it's always going to be x, y. So this first number for A is x, and then the second number is for y. So that's x, y for every single one of these. So if we're going to plot A, we have to find on the number line where x is, which x would be down here, y is here. So we're going to find 3 on the x, find 5 on the y, and where those meet at each other is where we're going to put the point, and we're going to go ahead and label it. Okay, point B is 0, 4. So on the x, we're going to find 0. On the y, because 4 being the second number is the y number, we're going to go where 0 and 4 meet, plot our point, and put our label. Point C is 6, 1, so 6 being x, we're going to find 6 on the x, 1 on the y, and where those meet is where we're going to put our point and label it. Okay, D is 8, 0, so 8 being x, we're going to find 8, 0 being the y, which would be right here. We would plot our point and label it. Last one, point E is 0, 0, which is also the coordinates for origin. And we talked about that in class as well. So I'm going to put point E. And also, go ahead and make sure you know that that is origin, which has the coordinates of 0, 0 when you're talking about x, y. Okay, moving on to the learning goal. Our first learning goal for this lesson is identify the 4 quadrants of the coordinate plane and the characteristics of points located in each. Learning goal 2, locate and plot ordered pairs of positive and negative rational numbers on a coordinate plane. Learning goal 3, determine the relationship between the signs of coordinate of ordered pairs that are reflections across one or both axes. Learning goal 4, use absolute value to determine distances on the coordinate plane. And remember in our last lesson, we found out, or a couple of lessons ago, we found out that absolute value is always positive. It can never be a negative number because it's talking about distance. Going on to learning goal 5, solve real-world and mathematical problems by graphing points in all 4 quadrants of the coordinate plane. Okay, we do have one key term. It is quadrants, and we're going to talk about the different quadrants on a coordinate plane. Okay. We are now on the next page. It's page 482, and it's labeled all about extending. Consider the coordinate plane that you have used to graph points where both the x and y coordinates were 0 or positive numbers. Number 1, based on what you have learned about number lines, 1a, what do you know about the number line that makes up the x-axis? Extend that number line and label it properly. So what they want you to do is they want you to go over here. And what we just learned is that our number lines are positive on the right and then negative on the left. So that's what they want you to do. They want you to extend it as much as you can and then try to label this, because we know our negatives are over here. A coordinate plane is really just 2 number lines together. We know number lines can be left and right. We know number lines can be up and down. Just like we talked about the building going up and down being a number line, you can do the same thing on a coordinate plane. Okay, so that was A. B says, what do you know about number lines that make up the y-axis? Extend the number line and label it properly. So again, the y-axis here, we have our positives, so that means down here, we need our negatives. So we're going to go ahead and put our negatives. Okay. Number 2, the point where the x-axis and y intersect is known as the origin. Label the point of intersection with its coordinates. So what they want you to do is they want you to go over here and they want you to label it with its coordinates, and we just talked about it. The coordinates of origin is 0, 0. Always 0, 0. That's how we know its origin, is when both x and y are 0. Okay. By extending the number lines that form the axis, you have created the entire coordinate plane. Number 3, how many regions are created when the coordinate plane is extended to all rational numbers? Well, you'll see we have one region here, 2, 3, 4. So that's 4 regions. So that's going to be our answer. It's 4 regions. Okay, we do have a key term. It's quadrants, and quadrants, if you have your key term journal, is on page 11 of your key term journal. Looking at the definition of quadrants, it says the regions of the coordinate plane are called quadrants. They are numbered with Roman numerals from 1 to 4, starting in the upper right-hand quadrant and moving counterclockwise. Number 4 says label each of the quadrants on your coordinate plane. So they said that we have 4 quadrants, and this is how we're going to label them. So looking here, starting on the upper right-hand quadrant, this is quadrant 1, this is quadrant 2, this is quadrant 3, and then quadrant 4 is actually labeled this way. So then that's our 4 regions, our 4 quadrants on the coordinate plane. Okay. Moving on, we're going to skip page 483. We're also skipping page 484. And we're going to go ahead and move on to page 485. Number 6, a teacher has all of the students who were absent for this activity come by after school to recreate the experience. For some students, their names are recorded, while for others, their location is noted with a letter. 6A, what are Mark's coordinates? So we're going to go to Mark, and remember, coordinates are always going to be x, y. So I'm going to go ahead and put that over here so that I remember that I need my x number, then my y number. So what are Mark's coordinates? Well, here's Mark. First, I need to know what number does he land on the x. Well, the number that he lands on for the x looks like it's 6. So that's going to be my first number. And we always put the parentheses around our coordinates with a comma. That's how you write coordinates. Okay, now looking at Mark, we need to find out what number for y. It's halfway between these two lines right here. Well, this line's 2, this is 4. Well, halfway between 2 and 4 would be 3, so this has to be 3 right there. But what would be halfway between that? Well, halfway between 2 and 3 would be 2.5 or 2.5. So you can write either one. Okay, so those are Mark's coordinates. 6B, what are the coordinates of point B? So we got to find point B. Point B is right here. Remember, it's always x, y, x, y. So we're going to go over here where B is, and we're going to see where would it land on the x axis. That's going to be a number between 5, because this would be 5 here, and 6. So halfway between 5 and 6, we're going to do the same thing we did for marks. It's going to be 5.5. 0.5 is the decimal form of 1/2. So if it's halfway between, it's always going to be 0.5 or 1/2. Okay, now find the y coordinates for B. We're going over here. We're now on the negative, but this is -3, but we're between 3 and 4, halfway between. So that's going to be -3.5 because it's more than 3 but less than 4. Okay, 6C, John had the coordinates of -4.5, 3. Which point represents John? So here, knowing that this is x and this is y, I'm going to find -4.5 on x. Well, -4.5, this would be -5 right here. So -4.5 would be here. And then +3. Well, +3 would not be going down. That means it would have to go up, where it would land on the y-axis there. So that would be point A. Okay. 6D, which students and or points are in quadrant 4? So we're looking at whatever student's name or point is in quadrant 4. Remember, this is 1, 2, 3, 4. It goes this way. So we're looking at every one of them that's here. So we're going to go ahead and start with the student's name, which is Anara. Then it's point D, B, and E. Okay? Why don't you try E, F, G, and H on your own? E, F, G, H on your own. 6E, what are Marshall's coordinates? Marsha's coordinates. So Marsha's here. We got to find, where does she land on X? Well, that would be 1. Okay. Where she lands on Y, well, that will be halfway between 4 and 6, which is 5. 6F, which student is the same distance from the x-axis as point A? Well, we got to look at that. Which student same as point A? So we're looking at point A. Let's see, and it says from the x-axis, so distance means you're counting these units here. So that's 3 units. Well, 1, 2, 3. It looks like Venna is 3 boxes away from the x-axis too. So Venna is the same distance as point A from the x-axis. 6G. Joseph had the coordinates 4 and 5.5. Which point represents Joseph? So we're going to try to find Joseph. Remember, it's x, y. So here we have 4. So on the x, I got to find x. And then 5.5, which is positive. So we're going to go up to where 5.5 would be. Well, that would be point C. What are Venna's coordinates? So looking at Venna, we need x first. That's halfway between -4 and -5. So that's -4.5. And then the y would be -3. Okay, so that's how we find our coordinates. Moving on, we're going to go ahead and move on to page 486. On page 486, please notice here, whenever you have this little mark right here next to any point, it is read as A prime. Okay. In this activity, we're actually going to write our coordinate that is a reflection of 4, 1, and we're reflecting it across the x-axis. So that's what we're doing here. We're trying to find out the reflection of the x-axis. So what they mean, so we're going to start with 4, 1. So this would be 4, 1 right here. Reflected across the x means you're going to hop over the x at the same point, but like if you were looking in the mirror, you see yourself exactly the same. So it's going to be the same coordinates, but in this case, our x is going to stay the same. And since we reflected across the x, now our y in this case is going to be negative. Okay, looking at B, we have negative 3, 4, and it needs to be reflected across the x on the same spot on the other side of the x. So that's still going to be negative 3 for the x, but now it's going to be negative 4. Go ahead and try C and D on page 486. C and D. Okay. We're going to start with 5 and negative 2. 5 and negative 2. And remember, it's going to reflect across the x-axis. So it's still going to be 5, but now it's going to be positive 2. Okay, D is 0, negative 7. So 0 on the x, then negative 7. Again, it's being reflected across the x. 0 stays the same, and now it's positive 7. Okay, 2. What did you notice about the coordinates of the original points and the reflections? Write a generalization for how the coordinates of a point and its reflection across the x-axis are related. Well, if you'll notice, all the x's stayed the same while the y's changed. So that's what we're going to write. X stayed the same. While y changed. Okay. Moving on to the next page. We're now on page 487. This is similar to what we just did on that last page, but now it wants us to reflect across the y-axis. Okay. So again, we're going to start with what they give us, which in this case is going to be 4, 1. So we're going to find where 4, 1 is. Now, instead of reflecting over the x-axis, we're reflecting over the y-axis, okay? So the y stays the same now while the x changes. Okay. Looking at the next one, we have negative 3, positive 4, and we're going to reflect across the y-axis again. So then the x changes, but the y stays the same. Okay, now go ahead and try these two on page 187. Try C and D on page 147. Okay, we're going to start with 5, negative 2. And we're reflecting across the y-axis. So in this case, your x is staying the same and y is changing. I'm sorry, opposite. X is changing, y is staying the same. Okay, D. -3, 0 reflected across the y. So then y is staying the same while x is changing. Okay. And just like the last page, it's saying, what did you notice? Well, again, instead of x changing now, we're going to have y that stays the same. And x changed. Okay. We're skipping page 487. Moving on to page 489. 7 says, for each pair of conditions, plot and label 2 points. Record the coordinates of the points. So 7a says 1 point is in quadrant 2. So let's go ahead and label this 1, 2, 3, 4. So we know it's a point that has to be in this quadrant. The 2 points are reflections of each other across the x-axis. So it can be really any point in this second quadrant, and then another point that is reflected across the x-axis. So it can be anything. So for this, we could easily say that it's -2 and +2. We could say that that would be A, and then reflected across could be A prime. We could say that. Okay, and then our coordinates, if we were doing that, A, we said would be -2, 2. A prime would be -2, -2. Okay. Now B, 1 point is in quadrant 3, so it has to have a point in quadrant 3. The points are reflected of each other across the y-axis. So it's a point over here, but reflected across the y. So again, it can be anything. We could say -2, -6 for B. And it could be reflected across the y-axis for B prime. Okay, so A would be -2, -6. Oh, I'm sorry, that's B. While B prime would be 2, -6. Okay, why don't you try C on your own, and then I'll go over it. Okay. 1 point is in quadrant 4, so it's in this section right here, one of them. And then the other point is a reflection of both axes. So it's going across the axis. So in this case, it's a little bit different. So if I did, let's say 3, 4, 3, -4, and this would be C, and it's reflected across not the X or the Y, but it's a reflection across both. So I'm going to do a reflection across both of them. So over here, I would have 3, 4 as the reflection, which would be C prime. So here I'm going to put C, and that coordinate we said was 3, -4, and then C prime, which would be -3, +4. Notice what happens. Okay, so this is across the x-axis, which we talked about when it's reflected across the x-axis, then the y changes. Okay, when it's a reflection of the y-axis, then the x changes. But here, this was a reflection of both axes. When it's a reflection of both axes, both of these numbers changed. to its opposite. Remember, for every positive, there's a negative. Okay, so if the number was originally negative, since it's being reflected, now it's going to be a positive. Okay. We are now on page 490. Number 1 says, consider points A and B. Use the coordinate plane to determine the distance from point A to point B. Okay. So where's A and B? Okay. So we're trying to find out what is the distance between these right here. Okay. We could simply count it. So if we counted it, we would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. That would be 13 units if we were to just count it. But there's another way to do it that I'm about to talk about. Describe how the coordinates of points A and B are similar. So the way that they are similar, they have the same y coordinate. Y coordinate is the same. Or y coordinates are 8. Both of these, their coordinates would have 8 as their y coordinate. Write an absolute value equation using the x coordinates of the points to calculate its distance. Okay, so to do this, we got to know what the coordinates are. Okay, so for A is 4, 8. B is -9, 8. Okay, like we said, the y coordinates are the same. Okay, since the y coordinates are the same, we're not going to use that on trying to find our distance. We have the x coordinates that are different. In this case, because we're adding the distance together, we could say the absolute value of 4 plus the absolute value of 9. And then remember, absolute value is always positive. There is no such thing as a negative absolute value when you're solving for absolute value. So the absolute value of 4 would just simply be 4 plus the absolute value of 9, which would simply be 9. And we add that together and we would get 13 units. So that's how you could write a absolute value equation to find the distance. Okay. Okay, let's try 2. Consider points B and F. I'm going to go ahead and write the coordinates for B and F here so it will help us. So we got B, which we have already said, -9, 8. Okay, F would be -9 and -7. Okay, use the coordinate plane to determine the distance from point B and F. Well, since it says to use the coordinate plane, that's what we're going to do. So we got to find the distance from B and F. And again, since we're using the coordinate plane, you can just simply count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So by counting, we found out that it's 15 units. Describe how the coordinates of point B and F are similar. Well, the ones that are the same are the x-axis. So in this question, we could say the x-coordinates are -9. Okay. So now, in order to find the absolute value equation using the y coordinates, so we're going to use the y coordinates. So we got absolute value of 8 plus the absolute value of -7. And remember, absolute value is always, 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 always positive. There's no such thing as a negative when you solve absolute value. So in this case, absolute value of 8 is 8, plus the absolute value of -7, which would be 7. Add it together, and you would get 15 units. Okay. 3, write the absolute value equation and calculate the distance from point D to -3, -5. So we got to find the coordinates of point D. Point D is going to be -3 to 4. Okay. So we're going to use that to try to write a absolute value equation. So the one that's different in this case is going to be your y-axis, okay? And, okay, so absolute value of 4 plus the absolute value of -5, which is actually 4 plus 5, which would be 9 units. Okay, going on to the next one. Next one is B. The one that's different is the x-axis here. So we're going to write that absolute value. So it's absolute value -7 plus the absolute value of 3. And again, absolute value is always positive. So in this case, it would be 10 units. Okay. Again, let's do the next one. Y is different, so we're going to do absolute value of 2 plus the absolute value of -5. And that one is going to be 2 plus 5, which would be 7 units. Okay, why don't you try D and E now? Okay, looking at D, we're going to do the coordinates of B, which we've already know. The coordinates of B is -9, 8. Okay, look at how our y coordinates are both positive. In this case, since they're both positive, we're actually going to subtract, okay? Because they're the same. They're both positive, not different or opposites of each other. So in this case, yes, we're going to do absolute value of 8, but in this case, we're going to do the minus absolute value of 2. And that one would actually be 8 minus 2, which then we would get 6 units. And the only reason why we're doing that is because both of our coordinates that aren't the same, so 8 and 2, they were positive in this case. They weren't opposites of each other, so that's why we had to subtract instead of add. Okay, now going to E, we need the coordinates of F. The coordinates of F, we've already said, was -9, -7. Okay, Y is the same, so we're looking at the X. We're going to write the absolute value of 8. And since they are opposites of each other, we're going to go ahead and add again. Absolute value of -9, so that would be 8 plus 9, which would get you 17 units. Okay. And that's it. Thank you for watching, and I hope you have a great day.